Hello everyone, I am Prateek. I'm here with my team Jaswant, Tapan, and Vikas. We are graduate students from Virginia Tech and research assistants at Commonwealth Cyber Initiative. We work under the supervision of CCI XG Testbed Director Dr. Aloisio da Silva. Today, we are going to demonstrate the first end-to-end ORAN ecosystem using SDRs and open source RAN stack SRS RAN. ORAN stands for an Open Radio Access Network. It is a non-proprietary version of the radio access network system that allows interoperation between cellular network equipment providers by different vendors. An open radio access network is a totally disaggregated approach to deploying mobile front haul and mid haul networks built entirely on cloud native principles and artificial intelligence. ORAN is an evolution of the next generation RAN architecture. ORAN transforming radio access networks towards open, intelligent, virtualized, and fully interoperable RAN. Using the ORAN ecosystem, we are going to implement a policy-based RAN slicing, emphasizing the first responder scenario. Policy-based RAN slicing refers to allocating the resources based on priorities of the first responder and making sure that the rest of the UEs also get enough resources and are not locked out of the system. For this setup, we have SDRs, which are X310s. We are using them for the RF front end, and the compute is in Intel NUCs. We have two general purpose UEs, which we are representing using X310s, and we have a first responder UE using a cell phone. We have developed certain dashboards which will help us walk you through the entire implementation. On your screen, you see the first dashboard, which is the non-real-time rig dashboard. In this dashboard, there are two parts, the policy control and the enrichment information. We'll be focusing on the policy control. Here you can see a policy type, which is 22,000. This tells the non-real-time rig how to communicate with the X app, which is present in the near real-time rig. The non-real-time rig consists of an intelligent application, which is known as the R app. It has a machine learning algorithm which is working inside it, which tells the allocation based on the data which it gets from the RAN. In our case, we have a policy conf, which is 0 when the first responder is not in the system and 1 when it is in the system. The three slices in the system are slice 1, 2, and 3. The first two are slices for general purpose users, whereas the third slice is for the first responder. Right now, since the policy is 0, the slice 3 allocation has been set to 0. I'm going to quickly switch to the near real-time rig dashboard. In the near real-time rig dashboard, which has been developed by our team, by one of the developers, Tapan. It has never been showcased before. It consists of two parts. The first part is the XApp catalog. It tells us which are the apps which are available and which are the apps that are deployed. We are using an open source app known as the NextRAN app. It has been onboarded and deployed. Moving on to the next part. The next part is the rig control. The rig control actually tells you the hardware that is existing in your implementation. We have a base station, which has 3 slices. Right now, the slice allocation of slice 1 is 65%, and it has a UE similar for slice 2, and the slice 3 is 0 since the first responder is not in the system. You can see the identification or the IMSI values of the users which are present in our system. Finally, we have the third dashboard, which tells us the speed that is corresponding with the proportion that has been allocated to the general purpose UEs. The first two UEs, the first two values are for the general purpose UEs. The value for the first responder UE can be seen on the cell phone. So now we're going to switch on the first responder UE, which is a cell phone. Once the cell phone is switched on, the first responder comes into the system. This information is transferred from the ENB all the way through the O1 interface to the R app. The R app has a machine learning algorithm which gets this data and identifies that the first responder has come into the system, and then it makes allocations for the first two UE slices as well as the first responder slice. And the first responder slice is given more priority. Once that happens, this change is allocated through the entire loop which we went through. So if we move to the non-real-time rig dashboard and I open the policy, you will see that the policy config has now changed to 1, and the slice allocation has been changed to 17, 17, and 66. Moving on to the near real-time rig dashboard, this information is also reflecting in these slices. So you can see that the value is changing because there is data going from the RAN all the way to the RAP, and these proportions are changing every few, as soon as the requirements of the UEs changes. The speed difference can also be seen in the last dashboard. There is a severe drop in the values that UE1 and UE2 are getting, and the first responder is getting more speed and more priority. So now you have seen for the first time the end-to-end implementation of the ORAN architecture. Thank you.